in our next example is we're going to find a partial fraction decomposition for such a rational expression containing a repeated linear factor. So at this point, we have a repeated linear factors. So what we need to do is we are going to find the partial fraction decomposition of x squared plus 10x minus 36 over x times the square of x minus 3. So based on the denominator that we had, it is already repeated because the roots is x is equal to 3, or x minus 3 times x minus 3. So first is so this example is just the combination of the distinct what do you call this, distinct linear factor and then the repeated linear factor. So the first one is, so this is, so next step is we need to put the so we have the factor x, so x is, this is distinct, so the only repeated factors we have here is x minus 3. So x still under the distinct, so a over x, so this is under the distinct linear factor. And then let's start x minus 3, so this is now in under the repeated roots or the repeated factors. So b over x minus 3 plus c over x minus 3 squared. So what if, so assuming if we have a repeated roots of x minus 3 raised to 3 or cube. So if our example is, or assuming that we have goes like this, so x times x minus 3 times x minus 3 raised to 3. So all you need to do is, so the same concept here. So yes, we have also this distinct x a, because x, the value or the roots here is x is 0, x equals to 0, so a over x distinct roots. So now let's start for the repeated linear roots, factors is the same also. Let's start with x minus 3, so x minus 3. So take note that this is repeated thrice. So next is c, so x minus 3 squared, and then the last one is plus d over x minus 3 squared. So again, if our example is we have x over x minus 3 raised to 3, so a over x plus b over x minus 3 plus c over x minus 3 squared plus d over x minus 3 squared. So that is how you are going to apply the concept of the repeated linear factors. So after that, so let's go back to our main problem. So next step is, again, is we need to multiply both sides this one. So let's multiply them both sides. So first, let's going to multiply the factored form of our denominator in here. So if you're going to multiply this in the left side, so the only terms that will remain is x squared plus 10x minus 36. So this is already here. Next step is we need to multiply for the first term of the right side, a over x. So the x will be cancelled out, and then the x minus 3 squared will be remained squared. So next one is we need to, so this is for the result that we had arrived or solved. So next step is we need to multiply x times x minus 3 squared in the second term. So based by inspection, the x minus 3 here, or one of the x minus 3 in our roots will be cancelled out, so the x will be remained, and then x minus 3. So here it is. So the last one is we need to multiply to the last term of the right side. So the x minus 3 squared will be cancelled, and then the remaining term will be only x. So this is cx. So again, based on the module that you had now, is that there are two methods that was stated there, but I'm more preferable. I more prefer these methods because this is easier if you know the techniques or the basic concept. So next step. So after having this kind of equation, so we already done with multiplying to each side. So this is already the result. So next step is we need to expand them. So we can identify what are the roots, the highest degree, and then the x. So x squared, the x squared, and then the constant. So for x minus 3 squared, so we need to expand. So a times, so this the x minus 3 squared, this is equal to x squared plus 6x plus 9. So yes. So again, a times x squared. So this is not plus, so this is minus. So the expanded form for x minus 3 squared is x squared minus 6x plus 9. So take note for that. And then plus b, so x times x is x squared, x times negative 3 is negative 3x. So plus cx, copy. So next step is, so we already expanded them, and we already identified the x squared, the x, and the constant. So next step is we're going to group them in according to the to the variable that we had. So for x squared, in this term, we have a plus, we have also coefficients for x squared, b. So yes, so the next one is the coefficients for x, all coefficients for x. So 6 times a, negative 6a, negative 6 times a, so this is negative 6a. We have also x here, so negative 3b. And then the same also with here, we have c times x. Plus, for the constant, we have only 9a. So we have no constant here and also here. So only in the first term. It's 9a. So after that is we need to apply the equating coefficients. So this is already our the simplified one. So now is we need to equate the coefficient. So again, let's start from the highest degree. So equating coefficient for the x raised to 2 or x squared. So we need to equate all the coefficients in the expressions or the functions with x squared. So in the left side, we have a coefficient, this is 1. So here it is, 1. In the right side, coefficient for x squared, so we have b plus a. So here it is. Next, so now you know what the advantage or how relevant these steps, if you arrive this answer, is that all you need to do is just copy. The coefficient. So for x squared, 1 in the left side, and then copy a plus b. So for in terms of x, so equating coefficient for x, all you need to do is just copy. So for the left side, we have 10. So for the right side, this is already, so negative 6a minus 3b plus c. So for our constant, negative 36, and then 9a. So this is how important or how relevant this method is in this kind of solution. So overall, if we derive, or we need to find the a, b, and c. So the first one that is easy to solve is the value of a, because in our third equation we could we already know by inspection that a is equal to negative 36 divided by 9 is negative 4. So after having the value for a, which is equal to -4, all you need to do is to substitute them into the first equation and into the second equation. So based on here, so a equals to -4. If we substitute in the first equation, so -4 let's transpose the -4 to the right side, so it will become +4, so 5. So this is already 5. So the last one is substitute the value for our a and then the value for b, so we could get the value of c. So overall, so the final answer for our, so the partial decomposition of this kind of a repeated quadratic factor that we had in our example is, which is x squared plus 10x minus 36 over x times x minus 3 squared. Again, this is under the repeated linear function, linear factors. It is equal to, so a here, so just substitute in here, so just observe the comparison. So substitute a is equals to -4 over x plus 5 over x minus 3 over c. Our c is 1 over x minus 3 squared. So this is our final answer.